So these are the kids that are consistent in each of those ones. So at least I have 3 of them. I'll be fine.
Then I tell Albertson that you have to put my entire life in.
Well,
Nah.
I don't think that test went very well.
Really?
I literally wrote penocytosis. Or peno starts with pena.
I know, it was so funny. I was walking right behind her. I was like, wait a minute.
I did like,
I feel like I've seen that
I was
before.
like writing
I looked down.
metaphase, what does it do? I wrote, I literally have.
No, what's all on the pitch?
A lot of stuff that I don't know.
Show her hand. What?
Show her my hand.
Hard or was it just you?
Showing at one time?
I didn't know that.
So it's not saying much.
What?
Well, in that case, too.
Where's our
I guess ours is good.
So from I was looking at some trucks. If I
Where'd
heard
you
that
guys do
wrong,
that?
and over here I said I heard you say, so I was looking at some trucks.
Yeah, ready with some
That's how you open about that after freshman. Okay. Connor, I didn't think you'd be that open about it after freshman year. I didn't think you'd be that open about it after freshman year. Drugs. I lost all my shirt. I had like 5 pieces.
Wait, oh, you remember that. So,
Okay, today what we're gonna do, we're gonna take some notes on section P.6, which is the rational expression section. We are gonna get working on that today, and it'll be due later this week, like Thursday. Okay, so that's the idea. That's what I wanna go over. Let's see. I think that's pretty much about the only announcements I have.
Out early Wednesday. So.
Yeah, so it's 1 hour early. Okay, but yeah, let's go through a couple notes here. Again, we're on section P.6. I want to finish this up today, P.6, which is the rational expression. The main thing that we definitely discussed last week, obviously the definition, but we did basic operations. Add, subtract, multiply, and divide. I believe on Friday we talked about division. So that's one problem I definitely want to cover today. We'll do an example of that. But if there's any specific type of basic operation that you're not comfortable with, we'll try to do one example of it today. But we're going to try to do a division problem today. So we have add, subtract, multiply, and divide. So, and again, division was our main thing on Friday. Then what we did is we introed, just a brief introduction. I believe we only did like one problem of it. We did complex expressions. So our goal today is to at least do 2 or 3 of these to make sure that we're comfortable with that. Once we get through them and you know kind of my strategies for that, we'll move on to the next part. Thank you. All right. So that's kind of our goal. Then again, our main topic here is why do we do this? It's because of this topic in calc, which is called limits. And we'll explain that when we get there. So we'll do maybe an example of that. I'll pull one from the book to kind of show you what I'm talking about there. All right. Now, before we move on, is there any questions about our order, what we're going to do here? Obviously, we're not going to do all these. But if there's a certain one, I know we're going to do at least one division. But is there any particular type that you're just not comfortable with? You want to see another example, kind of add these fractions together, subtract, multiply, or else are you going to do divide? Any particular ones that you know for sure that you're not comfortable with? Okay, we're good with adding and subtracting. How do you think I'm down here? Factoring, perfect. Okay, let's do a division problem. We'll just do one, and then we can move on to the new stuff today. Okay, I'm just going to pull a problem from the book because that's what I like to do. That way, you at least have a problem that you're going to potentially see. Actually, there's there because I don't know which problems I've actually assigned. I pulled those problems last week. So let's see, division problem. one of these. I don't care which one. Give me one of these bottom few. Maybe one that we didn't do last week, if you can remember. Fire away when ready.
X squared minus 4 over x squared plus 3x minus 10 divided by x squared plus 5x plus 6 all over x squared plus 8x plus 15.
All right. Any questions with the setup on this problem? Okay, we're dividing, not adding, not subtracting. Okay, is that good? I wrote it down. Okay. All right. Okay, so our goal is to simplify this problem down to its simplest form. Now, obviously, one of the questions that they can potentially ask you about this problem is what's its domain. So that's one of the problems we'll look at the very end. The domain are like what x numbers you could potentially use in this problem or not use. That's the idea. Typically, when you talk about domain, it's you in theory you want to use every real number imaginable, decimals, fractions, whatnot. But obviously, there's exceptions. You can't use like zeros on the bottom. Like zeros for a denominator make a problem. So there's certain numbers that we cannot use, and that's what we'll look at at the very end. But before we do that, what does the division sign mean? Yeah. But what do we need to do with it? Exactly. Yeah. We flip it, we multiply. That's what division is. It's really multiplication problem. That's all we're doing. That's what this is actually telling you. It's telling you to change this to multiplication, and then we're going to flip this fraction over. So this is what it becomes. That's the idea. That's what we're working with. We do the reciprocal of the second fraction. The first fraction didn't do anything. That one's fun. That's your, that's your dividend. That's the original item. We just leave that alone. But the item in the back needs to be the one that flips over. Okay. Any questions with the setup on that problem? How you start it? Now, remember, when we do division and we flip, now at this point, my rule is my little shortcut. You should factor it first. Factor it into pieces first. Once you have the pieces, then we can start simplifying this problem. And then what I'll do is the last step is where I multiply straight across. That's always my last step. That's the easiest way to do multiplication division problems. And subtraction is different. You find common denominators, you add across, then you factor last. The multiplication is different. So how do we factor this top part? Different squares, right? All right. So the difference of squares for that. To do that, it's 2 parentheses. Plus or minus x and x, 2 and 2, because it was 4, right? So you bring it 4 to be 2, and 2, you bring the x squared to be x and x. So that's the difference of squares. Now, what's the rest of the problem going to look like? What are these items? What's the rule? Trinomials. So you're going to have 2 parentheses, hopefully, if these work. Okay, good. So the first one, it will be plus minus. The reason why I know it's plus minus is minus sign in the back, so it automatically is plus minus. X and x. And then 2 numbers that will multiply to give you 10, but they're going to subtract to give you the 3 in the middle. It's going to be, 5 and 2? And we've got to make sure that the 5 is positive. The reason why I want the 5 to be positive, I need a positive 3 in the middle. That's the idea of it. Okay, and then I have x and 10. Okay. Any questions with the first fraction, how I factored it apart? I know it went a little quick. Sorry, I think you guys can go that. The next item over here, basically the exact same rules. Trinomial on the top. It's going to be, it looks like it's going to be plus plus, x, 5 and 3. They got to make the 8 in the middle, and it's positive, positive. These are the same. They're both pluses. Same thing down here. Plus plus, x and x, and then 3 and 2. That'll make the 6 in the back, but the 5 in the middle, and they're adding. Okay. So now that we're here, you're absolutely right. The next thing we're going to do is we're going to start canceling items out. How I do this? You cancel things out top, bottom first. Then once you get that done, then you go diagonally and see if there's anything that's left. So top down, if I do this, x minus 2 is for sure here and here. X plus 3. Okay, so there's top down kind of a thing. Now we're going to go diagonally. Yeah, so x plus 2, x plus 2, x plus 5, x plus 5. So it looks like everything canceled. So your answer in the very end is just the number 1. I mean, it's literally 1 over 1, which is just the number 1. It's not 0. Because it's still a fraction, right? There is still technically a 1 on the top. There's still technically a 1 on the bottom. That's why your answer is still 1. Okay, now you're probably wondering, well, how is that possible? How is that weird? Like, you're doing this and you're dividing and you're making the number 1. What they're basically saying is that these are the exact same fractions. You simplify them. That's why when you take something divided by itself, it gives you the number 1. That's what's happening. So if you were to actually graph this thing, it would just be a constant. So you'd be looking at, if you were to actually type this in the calculator, this is what you'd see. It would just be this constant line going across right through the number 1 going up. Something like this. That's what it would look like. But there'd be exceptions. There's holes in this graph. That you may not notice it, but there is a hole. Some of the original holes in the original problem. When we factor this apart, this is what? Plus 5 minus 2 down here. That's the parenthesis down on the bottom. Those are exceptions. I cannot use a negative 5 or a positive 2 in that original fraction. Those are numbers I can't use. So I know, like, right here at positive 2 for the x, there's going to be a little hole there. Even though it was removable. It went away eventually, but there's still a hole here. There was a hole at negative 5 down the road down this way. There's a hole here, even though the graph looks like it's going through it. The other ones, negative 3 for sure, or negative 2. Those are exceptions on that problem. So negative 3, negative 2, there's going to be holes here, even though they're removable. There's gaps. And before I even flipped it, there was a problem here. Because before I even went from here to here, these were originally on the bottom. So that's still an exception. So I'm not allowed to use on that, if you look, negative 5 or negative 3. Negative 5 and negative 3, which we already had taken care of. Because you have to look at the original problem, and every line you went through there to see what was on the bottoms and what numbers you have to throw out. Does that make sense to you guys, like how I do that? I go back. Now, if you're to actually type this in, like you're to actually type in Google, like graph, and you type all this, and you parentheses, division, parentheses, all that, it would actually show you a nice graph. There would just be little holes that you'd probably notice in there. Okay, maybe like right before you start homework today, I might throw it up on the board so you can actually see that graph. So you can see kind of what it looks like when there's removable versus non-removable kind of a things, like what the graphs will look like. Even though you don't have to graph yet, we're not in that chapter, or we're going to start graphing this by hand. It's nice to see like roughly what the graph looks like, the comparative thing, like when things cancel versus when they don't cancel. The subtle things. Okay. Any questions with division? That was good choice of now. Okay. All right. Let's do complex now. Complex is the one where we have fractions over fractions. Like it's just a monster of a problem. It just looks difficult. Okay. So we'll pick a problem there. Let's see. You choose really any of the problems down here, kind of a thing. Hopefully we didn't do it last week. You could potentially pick one of these, but okay. So say it out loud. What do we got?
3 over x minus 2 minus 4 over x plus 2 all over 7 over x squared minus 4.
Oh, that's the whole bottom. Yeah. Jeez. Oh, yikes. All right, so 7 x squared minus 4. Okay, yikes. Yeah, so this is complex. What makes it complex? You have fractions over fractions in a fraction itself. That's the idea. So, all right. So here's the trick on these problems. What I would do first, and this is going to seem goofy, if you can, I would factor the bottoms apart. The reason why I would factor the bottoms, like the denominators, I don't really care about numerators. I need to know what your common denominator is. That was the rule I told you last week, right? That this problem can be simplified if we multiply by the common denominator on that problem. So I'm going to start factoring this thing apart. Now, what I'm looking at basically is every fraction you have here. So I'm looking at like this thing by itself, this thing by itself, and this thing. Okay, so top left, is there any way I can factor the denominator? No. Top right? No. Bottom. That's, yeah, I can factor that apart. So this is what we're at so far. 3 over x minus 2 minus 4 over x plus 2 all over, and now on the bottom I can factor that apart because it's the difference of squares. So it's plus minus x and x, 2, it was the difference of squares down there. And now I think at this point you can kind of see what the common denominator is between all three of these individual fractions. It looks like it's going to be x plus 2, x minus 2. That's your common denominator between every point. So the rule that I do is like this, the shortcut when your problems are somewhat straightforward. This is, to me, this is an easy problem. You haven't seen like real difficult ones yet, but I consider this one an easy. What I would do is multiply this fraction, this entire thing, by the number 1. But instead of multiplying by 1, you multiply by the common denominator. So it's like this. This one I'm going to multiply by x plus 2, x minus 2. X plus 2, x minus 2. By multiplying by a common denominator, what happens is it cancels out all the fractions. It gets rid of those things so we don't have like fraction minus fraction, and all that good stuff. And so when you're doing this, this is the number 1. Agreed? Like they simplify to make 1. So I'm literally not changing the problem. But when you do this, you are taking this entire thing times this fraction, this entire thing times this fraction, and this entire thing times that fraction. That's what you're doing. The shortcut is you're going to take these items times the top, divide by the bottom. That's what you're going to do on each individual fraction. That's what I'm need to warn you of. So most people can do this in their head when they start going, but this is our first real attempt at doing something difficult like this. So I'll try to write it down so I can show you my process I do in my head. Right? So when I'm doing this problem and I'm multiplying this mess here to the top, and I'm multiplying this whole thing times that fraction, this is what I'm looking at. This is how I do it. I take the 3 times the whole mess, x plus 2, x minus 2, and I leave the bottom alone. Now you're probably wondering, why didn't I multiply to the bottom? You don't. Because technically, this thing right here is x plus 2, x minus 2 over the number 1. That's what you're looking at. That's that top part right there. So I'm taking this whole thing over 1 times that fraction. So really, these two items are only going to the top. Does that make sense to you, like what I'm doing there? And the bottom here just stays the same. Now, why I would do that? Like, why would I want to do that? Is because what cancels now? Yeah, these cancel out. I can do that in my head. Like, oh, I know that the x minus 2's are going to cancel here and there. So the only thing that's going to be left is the 3 and whatever thing didn't cancel. That's the process I have in my head. So that's what I'm going to do on the second fraction here. I'm taking the 4 times both of these things, right? And I'm doing this, typically I do this in my head. And then I'm dividing by the x plus 2, right? That's this thing. So I know in my head, these are going to cancel. That's the idea. Okay. Any questions with that first step? Okay, then on the bottom, you do the same thing. I'm taking that 7 times both the x plus 2, x minus 2. And then this bottom part here didn't change. It stayed the same, right? Because that was the denominator, and I didn't multiply the denominator. So what cancels on the bottom there? Yeah, pretty much everything, right? Those all cancel. So at this point, you don't have a complex fraction anymore. You actually have something that's really, really simple looking. And this is what you have. You have so now it's come down to this. We've eventually simplified this whole mess, this whole ugly thing, down to this. 3x plus 2 minus 4 times x minus 2. And on the bottom, we just have that 7 down there now. There's no fraction anymore. Everything canceled on that bottom. Do you agree that this is not complex looking anymore? This is actually really simple looking. And now we can go further than that. But the process here, I think what most people get stuck on is this first step. Like when you multiply by the common denominator, how do you actually do it? And that's what some people get in trouble with. So you're actually just taking this top times the top, this times the bottom. All right. Anyone stuck or not comfortable with how I did that? Okay. Now at this point, like I know some of you even said it, you can distribute this stuff and you can simplify all this thing down. So if I actually do this, I'll write that. What is that? 3 3x plus 6 minus 4x plus 20, or plus 8, right? Plus 8. And then this is all over the number 7. And the reason why, I know that this problem is going to simplify. You know, it's going to, there might be something I can do there. Maybe not. So if I actually do some work here, that turns out to be a negative 1x plus 14 all over 7. And you could leave it like that. That's totally fine. I mean, that's acceptable. You could technically put the 7 under each item separately. You know, negative 1/7 x plus 14 over 7. But, what that's telling you is that this thing's simplified to be a line. That's what it's all telling you. I mean, this just turned out to be a simple line like before. It actually has slope of negative 1/7, so it's dropping 1, running 7, and it started from the number 2. That's 14 over 7. So it's a linear equation when you get an algebra 2. But there was exceptions on that problem. What numbers were we not allowed to use originally? Go back to the original problem. Positive 2 or negative 2. Like there's going to be holes in that graph at those spots. Even though I know a bunch of stuff canceled, right? You know, you multiplied the common denominator and all these fractions canceled, and you ended up with a nice linear equation, something in slope-intercept form. And this is what it literally simplifies into. That's just a line with a slope and it starts to come to 2 on a graph. But there's still holes. There's going to be a hole at 2 and there's going to be a hole at negative 2. Because those are the exceptions. On the x-axis. All right. Questions, comments, concerns? Okay. That's complex. All right, limits. Let's talk about what a limit is. A limit in geometry is basically when you look at a problem and you're looking at like an equation, a graph, and you're trying to see what does that graph approach? What does it approach when it goes from the left and the right? That's what a limit is. So like, for instance, if I was going, you know, at the number 1 here, and I were to approach it from the left side and the right side, what would the graph be approaching for an answer? What would the y answer be as I approach 1 from the left and right and the x? What would the answer be up here? What is this number? 1. That's what a limit is. You look at it from the left and right. The best way I can explain it is what a limit is like you're theorizing what will the answer be at that number, right? So like at x being the number 1, what would the y answer be for it, right? So the idea is like, the best way I can describe it is the speed limit sign on the highway, right? Speed limit here on 18, what is it, 55 miles an hour? That's a limit, right? It's a mathematical term. The limit means you can be near it, either below it or above it, as long as you're near that number from the left side and the right side of the speedometer. So that means you can go slower than 55, you can go faster than 55. That's why they call it the speed limit. Okay, does that make sense? It's an actual math term. So that's why officers give you a little leeway up and down from that number. Not a lot. I mean, I think the cutoff is like 5 miles an hour, something like that. But 2-3 miles an hour, they're not going to pull you over. Unless you're in like construction zone. But that's the idea. That's what a limit is. So I think the best way my professor described it was when you think about what a limit is it's a theoretical answer to your problem. So for instance, if I started with, and this is the crudest way to explain it. If I start with a triangle, how many walls are there? 3, right? Imagine that all those walls were exactly the same size. So it's an equilateral triangle, or a regular triangle, that's the correct term, right? And you add more walls to it. So we add one more wall. What shape is that? Square, right? So that's a regular quad or a square. That's the correct term. Then we keep going. We have, the regular pentagon, where all the walls are the same, and you keep going. What would the limit be is if you made it 100 walls, 100 edges. What will that shape look like?
Almost a circle.
Exactly. You just did a limit in your head. Limit is theorizing what will this thing approach eventually. Like what number, what will it look like? That's what a limit is. So most people can kind of visualize, okay, if I keep adding walls, it'll basically look like this. If they're all exactly the same size, you put a bunch of walls to this thing, it eventually just looks like a circle. The more walls you hit. Because that's what a limit is. It's theorizing what will happen eventually. What will the answer be? So it'll look like a circle from the left and the right side, no matter how many walls you become. 101 versus 99 to look basically like the same picture. Okay, that's the idea. That's the way my professor described it in college. And that made sense to me. Now, why we do that? We have limits for certain problems. So, for instance, if I gave you a complex problem like this. Now that's a complex, and it's got variables, right? X's and H's. We could theorize what would this limit be on this problem if you approach the limit as X, or let's say H, approaches the number 0. Okay, as you approach 0. Now here's the thing. Can I just plug in 0 for H right now? No. That's why we use limits. Right? I can't just plug in 0. So they give you this idea of what a limit is, and this is how they write it. Limit as H approaches 0. So they want to know, theoretically, what will the answer be if I get close to 0. So what some people could do, some people go, okay, if I'm getting close to 0, I'll plug in half. I'll plug in half here. And I'll try that number out. And then I'll plug in the next number, and I'll plug in the next number until I get really, really close to 0. The 0 obviously won't work. And then that's positive numbers, right? So I'll try a 4, and I'll try, an 8th and a 16th. Or, dozens. Or they'll try negative. I'll try a negative half. Because that's the same thing. I can approach it from the left side. So I'll try a negative half. So that's approaching 0 from the left. So this is how they say it. The left side versus the right side. The right side is like the positive numbers, the left side is the negative numbers from that thing. Okay, that's the idea. That's the symbol that they use. And that's what we use limits for. It's actually what you're doing here. Limits basically come down to a simple formula, which is actually a complex expression. That's what limits are. Everything can be based on that. And you simplify it. You simplify that problem down as far as you can, so you can theorize, like, what will the answer roughly be? It could be something like that. It could be like a line. It could be approaching a line in your case. Now, obviously, like you guys said, I can't just plug a 0 in here. That causes problems. So that's why we do the common denominator idea. So then that way I can actually simplify this problem down to figure out what it will approach as I get closer and closer to 0. All right, is there any questions with how I do that, like what we use limits for?
So we have to do a limit problem?
No, that's something you get in calculus. But this is big picture idea, thinking out loud, why we're doing what we're doing, this is what we use it for. Theorizing, this is the first baby step to theorizing, what do these problems approach when you get to a certain number that you couldn't use in theory. So this is where you'd see it. Okay, I like to give you the big picture, because some of this stuff I know it's tough. A lot of you are like, God, why am I in here? Granted, it's a fair question. Pre-calculus and calculus are for engineers. That's what they use it for. Business majors use calculus because it helps. It's a process, it's a thinking process. But I do like to every once in a while fill in gaps. Okay, here's where you're going to eventually see it. Here's why we use it. If you want, we can do these types of problems. We can figure out those types of things. The book does a really nice job. They do one problem in the book. God, what page is that? It's like page 75 or something like that in your book. 78. I think it's page 78 in your book. They do a really nice job explaining one of those limits. They do one example like this, and they show you how they did it, like how it approaches from the left and right, and what the answer would actually be. So I'm not gonna waste your time by doing that. Don't even done working on it. But I just thought that was a really nice problem. That idea behind it. That was the stuff that I really liked in college. So, all right. Homework today. Homework today will be due on Thursday. So, let me put it on the board here. Here's your homework. Due Thursday when you walk in. Okay. If you're missing any assignments, please get those turned in. I'll be putting in, I think, what was that last week? Page 65, that was when we turned last Thursday. Those will be going in. So, if you had some late work, I know Tyler turned in some stuff, I'll get that in for you and stuff. Anyone's test still not showing up in their gradebook?
I haven't checked it.
Okay. Can somebody double check, take a Chromebook, look in there. I've been trying to change some of the categories and their weights, and then I hit submit again. But for some reason, your class is the only one where the grades aren't showing up.
What is
Like some sort of
homework
rule
weighted
that's
at again?
55% your grade.
And then test?
Tests are 40. So it's in the gradebook, and it is affecting your grade. But I want you to see that category, and that's what concerns me. That your guys' class is the only one that is not working. So here's your homework. Page 79, 8 through 14 evens. Make sure you're doing evens and not odds or anything weird. 17 through 27 odds. Now you can check the back, those are a little bit harder problems. 32 by itself. 35 through 39, some odds there. I gave you some odds, so you can check the back, see if you did it right. Number 58 by itself, that's a good one. And 62 through 68 evens. There you go, that's it. And that takes you up through complex. So there's basically adding and subtracting in the beginning. There's multiplying and dividing. And there's complex stuff.
Hey, mine's showing up.
It is? Okay, so I fixed a couple categories and I was hoping it does. So I don't know why it didn't last week. I did nothing different other than just mess with some numbers, hit submit again. Mess with some numbers, hit submit until it seemed like it was working. So, all right, the first one. All they're having you do in these first couple, simplify a fraction. They give you one fraction, they ask you to simplify it down by crossing out parentheses that have in common. And I believe they ask you for what the domain is. So like domain is like all real numbers, except you can't use these two numbers because that's what was on the bottom, like how they showed you on the board. So those are things that you need to worry about. Those are only the first couple. The next few, all they ask you to do is add, subtract, multiply, and divide. But I just kind of gave you a couple of each. And as you guys working, I'm going to try to type one of these in a graphing calculator and show you on the board so you can see this.
This board?
Yes.
You go get
Yes, you go get your shoe.
See, I was looking at that. I could get a truck and then get some under the seat cells. Or I could get like a Suburban. I thought it was a lot. I don't know.
Did you get what?
That's because he slams on the throttle.
Wait, is this 1999?
Oh no, this is a 97, 8 or 9. One of those. It's one of those three.
It's either 9 or 10.
It's when you're newer than us. This is a 99. Yeah.
Where'd you do it on?
So yeah, you should get 13. City 15 on that.
Yeah, maybe if you get it then.
And for me, I get drive around.
What on the highway? 16 on the highway?
No, Saturday on my
I get like 23 if I remember correctly right now.
I get 16 on city. I should.
No, I mean you do. I found
I
out
should.
of how it's treated. Like, he's slammed his ass.
You never know.
Okay, I get 30 on the highway.
Plus I can't check.
Hey, I don't know. What? How many miles are you doing? You reset the... Well, I was gonna say you could use, not no VD to reader, but, huh? Yeah, you just reset the every time you get gas.
Yeah, true.
Oh, I didn't reset the
Oh, yeah. I get what you're saying.
And then you see how many miles you got since the last time you got.
And then you add them up and then you change it back. I got you. Or, just go all the way, count out how many miles you're driving, count out which are highway and city, so you don't have to reset it. No, but right now I get 30 on the highway, you get 30, I found out why I've been getting such crap mileage, because I leave my windows open and I drive.
You broke down?
No,
What was that by?
that.
I broke down though.
Because cars are engineered to have their windows open when they're driving down the highway, and when I have my windows down, all that air is supposed to go back to the inside.
No, the pressures tested it. They went 50 with their windows down. They wanted to see what used more gas, having their AC on full blast or having the windows down and their both.
Wow.
Hold on.
Well,
I'm pulling that up.
I get a board drive.
No, because a trip down to Mason and back, my windows down, cost me about a quarter tank, and now it costs me about half a tank with my windows up. Or not half a tank, half of a quarter, sorry. Sorry. I was thinking
Quarter more with my windows down.
I was thinking half of a quarter. It's 1/8.
I actually wanted to
I don't know nothing about volleyball, but my mom, her mad.
But I actually wanted to do this on my college.
gotta dial it up.
Hey, John, I test those are the great book ready for now.
Yeah, what the line? Yeah, usually too hot. You don't want to.
No, I just forgot.
I just filled up today and it cost $30. Because I didn't know where my card went. And water
It's like a,
shoved in between my,
like 1%.
it was like half of it. And I didn't know that, so I went like a week and a half. I just like left it.
I was actually like, what the?
And I went on my card and I'm like, I need that. I'm getting that. And it was like,
Short answer, or
This weekend was the first time that my fast lane has actually come apart and that my car wouldn't start up right away. Because I was
Is
so
the
low
short
on
answer,
gas.
is that it?
yeah, there's like, there's two comparators.
if that ever happens to me,
The first,
I can't
one
see it.
is the stuff.
Because then I have to go 10 miles at a time. I had about,
Yeah.
I was in the red when I was out. So I had,
I want to see that.
I think when I'm in the red, I have like,
I don't even know what I'm in the red. I was in the red. I hit the red actually late, and that's when my
No, we
came
had
on.
trouble first.
And I was going like,
Yeah, because you don't have to take pressure when you stop.
I was going 55
And then
plus
we
about
gave us a chance at like 12,
25
and
miles.
we had 6 cents sugar, and then we were doing next.
that's what I was saying. I was like, maybe I'll be
You're
using this thing on my.
There's only been one time it was my
No
dad.
one would
I
time this.
we ran out of gas.
It was like pretty
We had our gas. And
It's always on empty. So we didn't know.
Oh,
I just did a
whose car does that?
bag.
Somebody's car,
Yeah, I did. Bag.
the gas meter doesn't work. So it's always on full, so you have to know how.
So you have to look at your house.
You just have to know how much is in there.
So you might as well just fill all the way.
I just fill up every single day. Because think, you're spending the same amount, it's just every single day instead of once every week or so.
Not right now.
That'd be too much work. Every day, every other day. You know when you're not.
Every other day.
You know how you grade that you have to wasn't finished yet? You can put the new grade and you left the unfinished.
Yeah. It'll be fixed. It'll be fixed, no.
I think it'd be smart to save them out though.
Like anything, it'd be like, my gas seems to go faster. I'm gonna like, a quarter or a half.
I was a little worried that you go on first weekend.
Hey, did I handle it back to you?
Yeah.
You want to hand it back?
Yeah.
I didn't even think about that. That's right, 'cause you turned it back, and I just saw it and I didn't even think twice about it, that's right.
Without the other two grades.
Oh, bro,
Well,
I
it's
have
like
1,000
back.
savings.
Yeah, 'cause you didn't look like you just got first time.
I only have like 500.
It's so good.
That's what I have. I have 500. I have a job.
Funny.
And then we
I
went
just want to
to
ask
the
her where me and the other did.
I'll be application numbers for.
What's the plan?
Application.
You know, I think
I have 549.
I have
Okay, well,
I have like
and
460,
because I
but I
don't
just
plan
got
on
$40.
I don't plan on everything nice and neat.
Well, I've been spending a lot.
Hey, does everyone have these written down? I'm gonna erase them.
Yes. Yeah. I spent like
She's like,
$90
she's
for
like,
the
"Well, take
bills and
it,
stuff. I like
they'll take your AC." I know, but I don't have
And
to
then I
pay something
spent
or
probably some on
actually.
Headlight.
I know.
And they were like,
Yeah, where are you going?
no,
What?
I'm going to like,
What does not even do that? When did I decide to go? Oh, a month and a half ago. What made you decide? That your radiology program?
no, it's been what, a month? And I'm just finally getting around to changing out the headlight. I've been driving around with my broken headlight.
Oh, even not hard. You just constantly have to go.
Well, we had to replace the entire assembly. But still, it's not even, it was really easy.